Hi all, welcome to the KT channel. Today I am going to explain the delays in Unit 1 in computer network. Topic delay. Definition. Delay in networking. Delay in networking is the time it takes for data to travel from the source to destination across a network. For example, I will take an example in system A sender and system B receiver. Here is the packet data. It takes time to travel from system A to system B. That time is called a delay. If the packet takes 20 seconds, if packet takes 20 seconds to reach A to B, that 20 seconds is called the delay. And we have the types of delays: transmission delay, propagation delay, queuing delay, and processing delay. I will go one by one. We explain the delays, types of delays. Transmission delay: the time taken to transmit a packet from the source to the transmission medium is called the transmission delay. For example, here system A. System A takes time to put a packet from that system to the onto the link or transmission medium. It is a link or transmission medium. System A takes 1 second to put a one packet from that system to onto the link. That is called the transmission delay. For example, 1 bit per second. System A takes 1 bit per second to put a packet from that system to the onto the link. 20 bits we have. It will take the 20 seconds to put a 20 bits onto the link. It is called a transmission delay. This delay depends on transmission delay depends on if many users or the devices are active at the same time, the delay can increases. If we have an example here, A and C, both users are using the same link, so the delay can increases, because if after using an A only after C will uses, if after using an C only after A will be uses, because both the systems of both the users are using the same link, so delay can happen. It is a one factor. Higher bandwidth helps the reduce the time needed to send the data. Higher bandwidth. If here only link bandwidth is very less, then the sending and data of the C will take lot of time. So for that, A system should wait lot of time, because to complete the process of the system A. If the system A is using this link is very small, to complete the system A process, it will take lot of time. Until that, system C should be wait. So if or the link width is very much higher, then both system A and system C both can use simultaneously. For example, if the road bandwidth of the road is higher, then A and C, both the vehicles, for example, both the vehicles can travel at the same time. So this is also one factor. If the sending and receiving a packet takes some time, because the operating system has to switch tasks. Like a simple example, if system A wants to send the data to the B and C, so system A should switches from one packet to packet. If the data is sending to the B, system A should switch to the system B process. If system A should send the data to the C, it should switch to the system C process. So it will take some time for switching and segregating the packets of B's process and the C system process, segregating the packets. So it will take some time. For this factor, the delay can happen. And another thing, the MAC protocol affects the delay when the multiple devices share the same time. MAC protocol affects the delay when multiple devices share the same network. If A and C devices are sharing the network data for the B system can decide MAC address of the B system can decide which system should send the data first. If B system wants to decided to send the data first to system A, then C system will be waits until A system process completes. These are the 4 factors of the transmission delay. Next, we will go to the propagation delay. Propagation delay is the time it takes for the data to travel through the network from the sender to the receiver. Simple. Sender A is there and sender B receiver. Sender receiver. Time taken to travel from the sender A to sender receiver. Packet takes time to travel from the sender to the receiver. That time is called the propagation delay. Simple. Propagation delay. Factors affects on propagation delay. Factors affects on propagation delay is the distance. If the sender to receiver the distance is more, the delay automatically delay will be more. And velocity, it takes less time if velocity speed is higher. If the packet velocity is more, high speed is there, packet is going with the high speed, then the uh, time delay will be the less, automatically delay will be the less. Now, third delay, queuing delay. When the packet reaches its destination, it may need to wait in a buffer before being processed. The time it spends waiting in this queue is called the queuing delay. Simple. Source and the destination is there. If the source sends all the packets at a time, it goes to the destination. Here, a destination system will take the time to process each and every packet. So it takes first fourth packet is received to the destination. So this system takes some time uh, to process the fourth packet. Then one first packet, second packet, and third packet. These three packets should be waits in a buffer. So this spending time and waiting in a buffer time is called the queuing delay, which waits in a queue. That time is called the queuing delay. When a packet reaches its destination, it may need to wait in a buffer. It will it may need to wait in a buffer. It will wait in a buffer before being processed. So until to complete one packet processing, remaining packets will be waited in a buffer. This time spends waiting in the queue. This spending time is called the queuing delay. Factors affects the queuing delay. Queue size is large, queue delay will be huge. This queue size is large. If here 4 packets are there, if the packets are 40, then automatically delay will be higher. If the queue is empty, if there is no queue, only one packet is there, that packet will directly processed by the system, no delay. If more packets are arriving in a short time, queue delay will be large. If system A sends the 40 to 50 packets at a time, the delay will be more. This the less number of links, the greater is queuing delay. For example, here source is there, another system is there here, that system also using the same link, only one link. For example, I will take another example. Here we have an example, system A and system C, both are using the same link. Here packets will be queued here. Systems A 40 packets, system C is 40 packets, so queuing delay will be more. Simple. These are the three factors that affects the queuing delay. Now I am going to the fourth delay, processing delay. After the packet reaches a device like a router, it needs time to checked and processed. This is called the processing delay. Simple. I will explain in a clear. Sender is there. Here one router is there. Switch 1, switch 2, and the receiver. The packet should sender to the receiver. It should reach the destination. So it comes to the router first. The packet reaches to the device like router. The packet reaches to the router. Here it needs time to be checked and processed. Here router will decide this packet to in which way it should go. It should go in a switch 1 way or it should go in a switch 2 way. For that sake, it will take some time to decide a path. That is called, that time delay is called the processing delay. Here some factors is there for the processing delay. Checking where to send the packet next. Router will checks or decide to send the packet to the switch 1 or switch 2. That is updating the TTL, time to live. Time to live means how much time it should take, switch 1 should take. Or if the switch 1 takes time, too much time, then it will decide to the switch 2. Like it will decide, it will decide like 2 seconds or 3 seconds. If the switch 1 takes the 4 5 seconds to send the data to the receiver, so next time it will not take the switch 1. That is called the TTL, calculating and verifying the header checksum. Header checksum means if for every packet there will be an IP address, MAC address. It will checks, and in next videos, in coming videos, you can understand that IP, how the router will works. So at that time you can understand this. So these are the 4 types of delays in delays topic. Thank you for watching.